This is very important question. For what values of the parameter m is the inequality modulus of x square plus mx plus 1 divided by x square plus x plus 1 strictly less than 3 satisfied for all real values of x? Before starting with the solution, we need to read this very important result. This is very helpful in the multiple choice questions also or other entrance exam questions. If fx is equal to ax square plus bx plus c, where a, b, c are belonging to the real numbers and a is non-zero, then first one, fx is strictly positive for all x belonging to R if and only if a is positive and the discriminant is negative. So for fx to be greater than 0, a should be positive and discriminant should be negative. And for fx to be less than 0 for all x belonging to R, if and only if a is strictly less than 0 and discriminant is negative. So for both these cases, discriminant is negative, but a is positive or negative in accordance with fx is positive or negative. So I'm going to use this result in the solution. So this is the given inequality, right? And this inequality is equivalent to minus 3 less than x square plus mx plus 1 divided by x square plus x plus 1 less than 3. Is it okay? Fine? Alright. Let's check whether this is positive or not, right? Because if this is positive, then we can multiply this throughout the inequality and the signs remains the same. So let's check. X square plus x plus 1. Consider. This is equal to, let's make the perfect square for this. So this is x square plus, I can write this x to be as twice 1 by 2 into x. Yes? So writing this as twice 1 by 2 into x. For making this to be perfect square, I need, already I'm having x square, I need 1 by 2 whole square. So adding and subtracting 1 by 2 whole square and plus 1, the remaining term. So this is equal to, for these three terms, we write x plus 1 by 2 whole square plus 1 minus 1 by 4. That is plus 3 by 4. So as I'm having square over here, this is positive. This itself is positive. So this sum is strictly positive. That means this denominator is positive. So let's multiply this factor throughout the inequality and the sign remains the same then. So this is minus 3 into x square plus x plus 1 strictly less than x square plus mx plus 1 less than thrice of x square plus x plus 1. Right? So therefore, if I consider these two, what I get, just take this negative 3x square to the other side, we get 4x square plus m plus 3, that is the coefficient of x, plus 1 plus 3, that is 4, greater than 0. So I'm getting this first inequality from these two, getting the second inequality from these two. So taking this x square to the other side, we get 3x square minus x square, that is 2x square, plus the coefficient of x, that is 3 minus m. Then 3 minus 1, that gives 2, greater than 0. Mark this as 2. Let me write this 3 minus m as taking minus outside as m minus 3. Doesn't matter. Okay. So these are the two inequalities I'm getting. So for this, I'm having my fx to be positive, and for this, what is a? A is 4, and this is also positive, right? Then by the result, the discriminant should be negative. So since the coefficient of x square, that is a equal to 4, is positive, the inequality 1 will be valid if the discriminant is negative. What is the discriminant for the first inequality? The discriminant is square of the coefficient of x minus 4 times coefficient of x squared into the constant. So that is equal to m plus 3 whole square minus 64. So this discriminant should be negative. That is m square plus 9 plus 6m minus 64 should be negative, or m square plus 6m minus 55 should be negative. Getting the factors for this, so this is m square minus 5m plus 11m minus 55 less than 0, that is m into m minus 5 plus 11 into m minus 5 less than 0, that gives m minus 5 into m plus 11 less than 0. So this means m lies between minus 11 and 5. Moving on to the second inequality, this one. For this again we are having the coefficient of x squared to be positive, that is a is positive. So this inequality will be valid if the discriminant is negative. So writing this again, since the coefficient of x squared, that is 2, is positive, then the inequality two will be valid if the discriminant is negative. So the discriminant is square of the coefficient of x, that is m minus 3 whole square, minus 4 times the coefficient of x square, that is 2, into the constant term, that is 2. That is m minus 3 whole square minus 16. So the discriminant should be negative. That is m square plus 9 minus 6m minus 16 is negative. That is m square minus 6m minus 7 is less than 0. Getting the factors for this, that is m square plus m minus 7m minus 7 less than 0. That is m into m plus 1 minus 7 into m plus 1 less than 0. That is m plus 1 into m minus 7 is less than 0. That implies m is strictly greater than minus 1 and is strictly less than 7. So this is another condition we are getting. The first condition is, from the first inequality we are getting this, and this is the second one. So from inequality 1 we are getting m to be strictly greater than minus 11 and strictly less than 5. From inequality 2 we are getting m to be strictly greater than minus 1 and less than 7. Let's mark this as the condition 3 and this as the condition 4. So the conditions 3 and 4 will hold simultaneously. Now in the condition 3, m is strictly greater than minus 11 and is strictly less than 5. In the condition 4, m is strictly greater than negative 1 and is strictly less than 7. So the common region is this. So these two conditions will hold simultaneously if m is strictly greater than -1 and is strictly less than 5. So this is the required value for the parameter m. Thank you.